In this short video, we'll briefly describe how to locate images in curved mirrors by making use of light rays. We always need to keep in mind that a luminous source sends out light in all directions. This represents an infinite number of light rays. We only need to follow a select few of these light rays, however, to find out exactly how an image is formed when the light hits a mirror. And all of this will always be guided, of course, by the first law of reflection, which states that the angle of incidence for the incident ray is always equal to the angle of reflection for the reflected ray. There are several light rays that, because of the geometry of the concave mirror, are particularly useful for us to use. The first example is that a light ray parallel to the principal axis, upon reflection, will go through F, the focus. The second useful light ray is just the reverse of the first, namely that a light ray through F, upon reflection, will emerge parallel to the principal axis. The third one is that a light ray through C, the center of curvature, upon reflection will reflect back upon itself, back through C. And the final one is that a light ray through V, the vertex, where the principal axis meets the mirror here, will reflect such that, again, the angle of incidence equals the angle of reflection. In order for us to locate an image, we need to follow at least two light rays from our particular source. And if we look at the upper diagram, we see that our candle is outside of C, and we can follow our two light rays. Our first light ray is in parallel out through F, and our second light ray is in through F out parallel, and we can see that they actually cross right here. This is where the image is formed, and we can see that it'll be smaller, inverted between C and F, and it's a real image because light is actually arriving at the image location. If we move our candle so that it is upon C, we can still use our same two light paths here, in parallel out through F, in through F out parallel, and we can see that this time the image is located here. It's the same size, it's inverted, it's at C, and it's real. If we now move our candle so that it's between C and F, we can again use our same two light rays. We note that this time they intersect back here, and so this is where the image is formed. The image is larger, it's inverted, it's outside C, and it's real. If we now move our candle in so that it's on F, the focus, we actually have a special case. We can see that if we follow our light rays in parallel out through F, and in this particular case, we're going to have to follow the fourth example here, in through the V, the vertex, and back out again. We can see that our emergent rays here, our reflected rays, are parallel. They do not cross, so no image is formed. Even if we project these rays back behind the mirror, we can see that they never cross, so when the candle is on F, no image is ever formed. Our final example is when we move the candle in between F and the mirror, and again we've got in parallel out through F, and this particular time we're going to use, it looks as if it's come through C, will reflect back upon itself through C. This time the eye will see these reflected rays, they're divergent this time, and so what the eye will do is it'll project these light rays back, so the eye will think that the light has come from back here, and this ray back here will project back to here, and so what the eye will think is that there is an apparent light source back here. Now we of course know that this cannot be the case because this mirror is actually an opaque surface, and so the image that is formed back here is a virtual image. All right, it is larger, it is upright, and it is behind the mirror. If we go to the convex mirror, we can see that we have a similar set of rules, in parallel out through F. Now it hasn't really come from F, but it looks like it has come from F. All right. In through C, back through C again, and again it looks like it has come from C, but hasn't really because of course the mirror is opaque. And in through F, or aiming towards F, out parallel to the principal axis. If we make use of those rules right here, we've got our candle in parallel out through F, or it looks like it has come from F, so it looks like it has come from back here. And if we follow this light ray here, in through F, or aiming towards F, out parallel, all right, that this light ray looks like it has come from here, and so your eye will project these divergent rays backwards, will form a virtual image back here that is behind the mirror, that is upright, that is smaller, and that is virtual.